Hello everyone. Today we will be discussing the concept of directions. Now this topic has been very frequently asked in the various law exams. So in this session we will understand the different directions. We will also look at how to trace movement while solving directions questions. We will be revisiting Pythagoras theorem because that is being extensively used when we solve questions based on directions, and also we will be solving couple of practice problems. So let's start our session. Now, firstly, the questions based on the concept of directions can be categorized as follow, which you can see here. Questions can be asked about the distance between the end point and the beginning point. Questions can be asked based on direction vis-a-vis, like if there's a particular movement of a person has been given, and it could be asked that now he is in which direction with respect to the starting point. Then questions can be based on the angular movements rather than the left, right, or the clockwise, anti-clockwise movement. There will be angular displacement thing would be given, data would be given based on the angular movement, and then you would be asked questions based on that. Shadow based questions have also been asked in couple of questions, and we can also see there are puzzles that are being framed around the concept of directions. So we will be taking each of these concept or a different kind of the variety of questions one by one. So moving on, let's see what are the four major primary directions. We know about north, south, east and west, which are our primary directions. Okay. Now, the topic of directions requires you to draw a diagram whenever a question has been given, and usually it's the movement of a person. He starts from a point, he moves towards the north or a left and right turn. That all data has been given. So it's very essential to make a diagram. Now, whenever we make a diagram, from a starting point, whatever be a starting point, if we're drawing on a piece of paper, up is always considered north, down is always considered south, right is always considered east, and left is always considered west. These are our four major primary directions. Apart from these primary directions, there are four secondary directions also, which happen to be in between the primary directions. So exactly between north and east, we can find northeast. The north and west, we can see northwest. Southwest comes between the south and the west, and southeast comes between the south and the east. Now, if we look at angle wise, the angle between west and south is exactly 90-degree. Okay, whereas these secondary directions, so this angle is 45-degree, and even this is 45-degree. Now let's discuss the concept of left and right movement. So this is very crucial to the directions questions, because if we get even one left or one right turn wrong, our entire diagram could go wrong, leading us to an incorrect solution. Okay, so this is very simple. Whenever a person facing north, if he takes left, he will move towards west, and if he takes right, he will move towards east. Look at here, this person is moving towards north. If he takes a left turn, he would be now facing west. If he takes a right turn, he would now be facing east. Similarly, a person facing west on taking left will face towards south. A person taking right will face towards north. So somebody who's walking west, left turn will take him down, and the right turn will take him up towards north. A person facing east, left turn will take him towards north, and right turn will take him towards south. So if someone is moving towards east, Left turn will take the person up towards north. Right turn will take the person down towards south. A person facing south, left will take towards east and right will take towards west. Okay, so left is towards east and right is towards west. Remember, north and south have exactly opposite left and right turn, and similarly east and west have exactly opposite left and right turns. And this is something you need to take extremely good care of, the left and the right turns. The clockwise and the anti-clockwise movement. You might have heard of these terms quite often. So whenever a person is moving towards his left side, the movement will be in the anti-clockwise direction. Okay. Supposedly a person is walking towards north and he moves towards the left side. That will be the anti-clockwise movement. And if the same person moves towards his right side, that will be the clockwise movement. Also, just there's an important note here. When a question says that someone has taken a left turn or a right turn or moved towards the left or the right side, we assume the movement is happening or is at an angle of 90 degree. If someone is walking north and we say he takes a right turn, so right turn would be at sharp 90-degree turn, like this angle has to be 90 degree. So the turns are taken at an angle of 90 degree. Keep that in mind. Pythagoras theorem. Now this theorem is extensively used when we are being asked to find the distance between the starting point and the end point. Okay, couple of time when we look at the starting point and the end point, and we see the shape is coming out to be a right angle triangle. Okay, and if we draw a straight line connecting the starting point and the end point, that kind of becomes the hypotenuse of a right angle triangle. And the moment you have a right angle triangle with you, the concept of Pythagoras theorem comes into the picture. Now what does Pythagoras theorem states? It states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So the longest side, the slanted side, is called hypotenuse in a right angle triangle. So in a right angle triangle, C square will be equal to A square plus B square. This always holds in a right angle triangle. Now there are some famous Pythagoras triplets. Now triplets reduce our calculation time. Now what do we mean by triplet? If I have a right angle triangle with one side as 3 and other side as 4, the hypotenuse will always come out to be 5, because 3 square plus 4 square is equals to 5 square. Okay, that's why we say 3 4 5 is a triplet, because it follows the digits or the values follow Pythagoras theorem. Now how do we use it and what is the point of remembering the triplets? Now if in any question, if in any right angle triangle you see the two sides to be 3 and 4, without any hesitation you can conclude that the third side is going to be 5, provided it's a right angle triangle. Now it also helps, we can see a couple of times we can see the multiples of 3 4 5 as well. Let's say in a triangle we see one side is 6, other side is 8. Okay, now 6 and 8, if we look closely, they are in the ratio 3 is to 4. And if I know this is a right angle triangle and two sides are 3 and 4, the third side has to be 5. So the third side would be 10. Why? Because 3 into 2 6, 4 into 2 8. So the third side should be proportional to 5 and 5 into 2 10. So I will not be doing my calculation like this here. I can skip this calculation if I remember the triplets with me. Another famous triplet, again that is which is being widely used, is 5 12 13, because 5 square plus 12 square is equals to 13 square. So we can cross check here. 25 plus 144 comes out to be 169, and 13 square also happens to be 169. So if I see a triangle where this side is given to me as 26 and this is 10, and if I see the ratio 10 and 26, this is 5 and this is 13, and I know, and it is being given to me that it's a right angle triangle. So we know 5 12 13 is a Pythagoras triplets. I've already been given the two sides which are proportional to 5 and 13. So the third side should be proportional to 12. Now 5 into 2 10 and 13 into 2 26. So the third side which is not given to me would be 12 into 2 24. And that's how remembering the triplets can reduce our calculation time. So these two are the most commonly used triplets, and I will strongly suggest that you remember them. There are a couple of more triplets which can come handy, like 5 18 17, 9 40 41. So if you can just keep a track of these four, should be enough. Another important thing while solving directions question is the usage of scale. Let's see, there's some data given here. A person starts from his home, walks 5 kilometers in the north direction. So let's say this is the starting point and he's walking in the north. So this is 5. Then he takes a right turn. So if we are walking towards north and taking a right, we will start moving towards east and walks 10 kilometer, and then again he takes a left turn. If you're walking in east and you take a left turn, you again start moving upward towards north and walks 10 kilometer. So these are the two diagrams for the same scenario. Now I will rule out, if I'm saying this is diagram 1 and this is diagram 2, I will rule out diagram number 1. Why? Because the scale has not been followed. I have in fact expressed 5 of the same length as I've expressed 10 kilometer. So though we will not have the actual scale in the exam hall, we need to slightly take care of the scaling using a rough measurement. I cannot draw lines of depicting 5 kilometer and 10 kilometer of the same length, because if I'm doing so, I would get my entire question wrong. So 5 and 10, the difference should be visible. Okay, this is 5 kilometer and 10 has to be more than that, and as I said, we have to take a little bit of rough measurement, and the 10 should look like double of 5. So we'll go with diagram number 2 here. So scaling is something which we have to take care of, and using our rough estimates. Now let's move to some practice problems. So a man goes 3 kilometers east from point A, then takes a right turn from point B to move 4 kilometers to point C. What is the minimum distance between point A and C? Let's have a look at the diagram first. So this is how the movement should look like. He's starting from point A, he moves towards east to reach point B, and he's traveling a distance of 3 kilometers. After reaching point B, he's taking a right turn. He was moving in east direction, and taking a right turn will take him to down south, and he travels 4 kilometers to reach point C. So this is the diagram. The minimum distance between point A and C would be a straight line connecting A and C. Now this looks like a right angle triangle. So I have a right angle triangle with one side is 3, other side is 4. I know the third side should be 5 only. Now look at the questions here. So the minimum distance point between point A and B, between point A and C, sorry, it's 5 kilometer. That has been answered here. Now, in which direction is he with respect to the starting point? His starting point was A and he is at point C. So, if he's standing on point A and looking at point C, he is in which direction? Answer should be south east. Because if I'm standing at point A, this is my east and this is my south, and C happens to be midway between that. In which direction is the starting point with respect to C? Now he's standing at point C and looking at point A. So answer to this should be northwest. Why? Because if somebody is standing in point C, this direction would be north, and here with respect to point C, this would be west, and A happens to be between north and west. In which direction is he walking towards point C? When he's walking from point B to point C, he's walking in the south direction. Let's have a look at another question. Ajay goes 6 meter north and turns right and walks 8 meter. Again he turns to his right and walks 4 meter. After this he takes another turn to his right and walks 8 meter. So what is the distance between his current position and his starting position? Okay. So we'll plot the diagram. If this is the starting point, he is going towards north 6 meter, turns right. If you're walking north, your right turn should be in the towards east and walks 8. Just take care. I've deliberately kept 8 slightly bigger than 6. He again takes a right turn. If you're walking east and if you take a right turn, you'll come down. Walks 4. Now you're walking south and you take a right turn. So if you're moving south and you take a right turn, you will be moving in the west direction. So he again walks 8 meter. So he reached here. If A is the starting point, B is the end point. Okay. So what is the distance between his current position and the starting position? So this becomes, since all these turns are 90 degree as we have discussed, this kind of becomes a rectangle. So if this is 4, this is also 4, and we know this entire is 6, so this balance should be 2. So the answer should be 2 meter. Okay, a child is looking for his father. He went 90 meter in the east before turning to his right. He went 20 meters before turning to his right again to look for his father at his uncle's place 30 meter from this point. His father was not there. From there he went 100 meter to the north before meeting his father in a street. What is the smallest distance between the starting point and his father's position? Now that's how the diagram would look like. When we put all his movement, the final diagram would look like this. So he started off from this point A, and for 90 meter in the east he reached point B. Taking right, walked 20 meter, he reached point C, and again took a right, walked 30 meter to reach his uncle's place, which is point D, and from here he took 100 meter to the north before meeting his father in the street. So point E is the point where he met his father. Now what is being asked? What is the smallest distance between the starting point and his father's position? Now the smallest distance between A and E would be a straight line connecting A and E. And now this AFE becomes a right angle triangle with this side as 60 This balance is 80. So we have a right angle triangle like this. 60, 80. We are supposed to find out this. We will again make use of triplets here, because when we look at the digits 60 and 80, we see they are in the ratio 3:4. And it's a right angle triangle. The third side should be proportional to 5. So this should be 100. We'll go with 100 meters. Another question. Vijay walks 10 meter towards south. So we'll plot his distance. From there, he takes a U-turn and walks 6 kilometer. So if he's walking towards south, U-turn would, that means he will turn 180 degree. So he'll again start walking towards north. He walks 6. Let's say this is 6. Then he takes a left, walks 3 kilometer. So if he's walking towards north, his left turn would be like this, 3. What is the distance and direction of his current location with respect to his starting point? His starting point was, let's say this is point A and this is point B and this is C. BC is 3, AC would be 4. 10 minus 6. This would be 4. And we are supposed to find out what is the distance of AB. Length of distance AB. Again we get a again we get a right angle triangle ABC with two sides at 3 and 4. So we'll get hypotenuse as 5. So that's the distance 5. We can see three options have 5. So now the other part of the question, the direction of his current location with respect to his starting point. So it's like he was here. A is the starting point and B is the end point. So this direction would be, this is your west and this is your south. So direction is southwest. Answer should be 5 kilometers southwest. Another question. Akash started walking towards north and walked 5 kilometers. Then he turned right, walked for 3 kilometers. He took another right turn and walked 5 kilometers. It's again taking a right turn that will take him to down. And finally, he took a left turn and walked 2 kilometers. So if he's walking south, his left turn would be towards east. So question is, what is Arjun's current direction from his starting point? So he was here. This was the starting point and he's particularly here. So if you look at the direction, he is towards the east of his starting point. Let's solve this question. Jaya is 12 meters east of Mani. So I'll plot Mani first. Jaya is 10 meters west of Hina. These two data has been plotted. Hina is 15 meters north of Girish. Girish, which is 7 meters east of Lokesh. So here we would have Lokesh. Okay. Then we have Lokesh is 19 meters south of Xylo. So Xylo would be like this. This entire distance would be 19. Xylo is 8 meters north of Brajesh. So Brajesh should come somewhere here. And finally, Brajesh is 7 meters east of Vishesh. Here we can see Vishesh. Okay, now the question is, Vishesh is in which direction with respect to Hina? So here we have Hina at this place. And whereas Vishesh is at this point. So the direction would be southwest. Answer would be southwest here. Savita travels 7 kilometers towards east. Let's plot this one. Savita travels 7 kilometers towards east. Let's say this is her starting point A. Then travels 25 kilometers south. So she goes down 25. She then travels 10 kilometer towards east. Then travels 6 kilometer towards her right. So now she is traveling towards east. Her right should go down. Okay. After this, she travels 3 kilometer towards west and stops. So she again comes back towards west and stops. So this is the end point. Now the question is, how far is she from starting point in vertical direction? Now, very important thing is this word vertical direction. We are not asking the minimum distance between the starting point and the end point. Vertically, she has traveled, how much down she has traveled from her starting level. So it's like if she was at this level and she has now at this, what is the vertical distance? This vertical distance is 25 plus 6. This vertical distance is 31 kilometer. So she has traveled 31 kilometer in the vertical direction. Let's have a look at one more question. My office is to the east of my house. So I plot my house first. And my office is to the east. So this is my office. My sister's office is to the southeast of my office. So this would be south of my office. This is the east of my office. So here I would say this is my sister's office. A park is to the south of my office. A park is somewhere in this here. So park is in south of my office. Okay. Now the question is, in which direction is my house located with respect to the park? So if I'm standing at the park and looking at my house, I'm looking in which direction? So when you're standing at park, this is the north and this is the west. So standing at park, when you're looking at the house, you're looking in the northwest direction. So thank you. Thanks a lot. I hope now you have built some confidence on the questions based on distance as well as direction. In the next session, we will look at the questions based on angular movement and the shadow based question, and also we'll look at the couple of puzzles based on directions. Thank you.